Good afternoon and welcome to Metro Home Theater Tech Tips. I'm Brent.
I'm Adam.
And welcome aboard. So what have we got today, Adam?
Well, today is actually kind of a heavy day of data. There's going to be a lot of information that we're going to get out there today. It's primarily going to be talking about, this is part one of a multi-series episode talking about networking.
Or is it multi-episode series?
Sure, we'll go with something like that. I don't even know what I said. But we're going to do quite a few episodes on networking because, to be perfectly honest, there is a lot of episodes on networking. So first and foremost, everybody who's checked in with our episode today, thank you for coming in. It's great to see y'all here as always. If you have any questions about what we're talking about today, you can of course leave it over here in the chat on this side. Or if you're viewing this after the fact, you can put it down in the comment section below. And then, as always, like, share, subscribe, give us a thumbs up. Hit that little bell notification if you do subscribe or are subscribed. It lets you know when we do go live, which of course is every Wednesday at 3 p.m., except for, of course, last Wednesday because
you were out of here.
I was out of here. I was in quarantine it was like Tuesday, and it was like, oh darn, we don't have the ability to set something up within the amount of time that we have in order to go live. So we unfortunately had to take a break.
But on a more positive note,
yeah,
before we get into that,
yeah,
you shared some wonderful news with me last week, because as you recall, we begged, clawed, and pleaded our way to 1,000 subscribers.
Yeah.
Where are we at now?
We're at 1,226, I think.
Which is awesome, and
yes,
thank you.
Thank you so much for subscribing. Of course, it makes our world great because it lets us know that we're doing something good for you. And as always, if we're giving you good information, please share it out to everybody else. Put it out there on the different platforms, IP or PI or whatever. IP,
Remote Central.
Remote Central, everybody else. We really appreciate it for that. And actually, that kind of leads us into what we're talking about today, Brent.
Yeah, and by the way, just so everybody knows, because I am not near as intelligent on this topic as Adam is, he has created me a cheat sheet.
Now, you're not nearly as up-to-date on this as I am, and I'm nowhere near some of the people out there that have to do with all of this. So today's episode, what we're talking about today, of course, is, let me hit the button here, make sure it actually works. What are IP addresses and MAC addresses? So this is going to be the first part of this multi-part series.
I have an Apple.
You have an Apple?
Mac.
A Mac? Well, your Mac has a MAC address, but it's not.
So it's not that Mac?
No.
Is it a big Mac?
Wrong Mac.
I'm going down.
Now there's Mac back here in maintenance.
No, he's retired.
Oh, he is retired. Did he finally retire? I didn't know that. Okay, Mac, have a wonderful retirement. So what we're talking about then today, of course, is IP addresses and MAC addresses. So we're going to start super basic with all of this. Again, if you guys have any questions about what it is we're talking about today, or if you have your own interjection, let me know over in the chat section over here. If I say something wrong, please fill me in. I am nowhere near a professional, super professional. I am not.
That was an interesting qualifier.
I'm not classically trained when it comes to networking and other items like that. So please, if I say something wrong, let me know over in the chat or down in the comments. Or you can reach out to us directly, of course. You can reach us here on our tech support, 386-492-8584. You can email me at adamr@metrohometheater.com, or you can email Brent
at brentm@metrohometheater.com, or 866-839-9187, extension 2203.
Right. And actually, you can see our number down here on that, or of course, you can find our contact information at metrohometheater.com. So what we're going to do is we're going to talk about IP addresses first. And I was going to talk about MAC addresses first, but honestly, there's not a whole lot to talk about with that. So we're going to go to IP addresses first.
Okay, so according to your sheet here for me.
The cheat sheet?
The cheat sheet, because I am an idiot.
Okay.
You're going to give us a brief history of how and why we are where we are.
Yes. So what is an IP address? Okay. What we have here, of course, like you said, the history of IP addresses.
Well, I'm going to assume it means Internet Protocol.
It does. Yes, it does. That is the actual, well, intellectual property.
Installationpros.com or .org?
Sure, yeah. But in this case, we're going to be talking networking specifically. But so pretty straightforward. Everyone is fully aware, or at least if you've dealt with anything that's networking involved, or even if you really haven't, you've probably heard the idea of 192.168.1. whatever.
Which is the default for most products.
For most products. That was kind of the go-to for that.
10.0.1s, but...
Right. Now, IPv, that's what IPv4 is. That's the fourth iteration of IP addresses, or Internet Protocol addresses. So that was actually, the history of it, it was first used by ARPANET, ARPANET. That was fun. It was first used by ARPANET back in 1983. Which is actually kind of fun because my sister was born in 1983. I called her up and said, "Hey, you're as old as the internet as we know it today."
You're really going to rub that one in today, aren't you?
And then there's you. So you predate. How's Barney?
Him and Fred are doing well.
Okay,
thank
good.
you.
I'm just checking. Yeah. Okay.
Thanks.
So then, of course, we have now IPv4 is widely used across the world, and it's just used everywhere. Then of course, they started to realize even back then when it was first produced, and I'm going to get into the numbers of them, but they started realizing that they were going to run out of addresses really quickly. And so what they did was they started working on different versions. So there was there's actually versions 1, 2, 3, and then of course 4, which is used right now. And there's version 5, which isn't really used. It was more like a test version. Then there's version 6. So IPv6 is actually where the world is going to go next. And I'm going to go into a little bit of detail about IPv6. I'll be perfectly honest with you. I don't know enough about it to really talk in detail about it, but I do know the fact that it is an obscene amount of addresses that are available, but we'll talk about that later. But like I said, there are multiple versions that were created, versions 1, 2, 3, 4, 5, and 6, and there's actually all the way up to version 9. Which is currently being used, and they're just using it for study right now and for certain out of the bounds uses right now. They're going to probably, maybe eventually in the next 30 years, we'll make it to version 9 or something like that. But right now, not a whole lot. So,
just out of absolute curiosity, have you seen a address quantity count for version 9?
No, and to be perfectly honest, I didn't go into the other versions because that's not really what I want to get into today. Because there's a lot of information about that, I'm sure, out there on different white papers that different people have out there. You can call up a buddy that works at MIT or something like that, or goes to school at MIT, and maybe they can tell you more about it. I know lots of
those guys. Yeah.
I'm sure you do. Yeah.
Yeah.
I mean, Jeff might know a little bit. Where did Jeff go? Jeff didn't go to MIT, did he?
No, he.
Who am I thinking of?
I don't know.
I don't know where. Anyways, moving on. Okay, so. The first part,
that is a lot of addresses.
That is a lot of addresses. So we'll talk about what is the structure of IPv4. So IPv4 is a 32-bit structure. Okay, it's 32-bit size. And what that basically means is that, and this is actually important, you and I understand bit rates or bits because we use it in HDMI all the time. That's how we figure out bandwidth requirements. But this is just an addressing. So it's a 32-bit word or 32-bit size. There's a total of 4,294,967,296 addresses available.
Possible combinations.
Possible combinations of addresses available in IPv4. So that's a lot. To be perfectly honest, that is a lot of addresses. But the truth of the matter is that right now, there's so many devices out there that are using IPv4 and that use multiple IPv4 addresses that we're running out. And so the need for us to do something different with IPv6 is definitely there.
Now, before we get into that, I do want to cover the difference between an internet address and a local address.
Yes.
Because the fact that you've got 4,294,967,296 addresses is internet addresses, not local addresses. So you can have a large amount of devices sitting on a single IPv4 address.
Correct, and that's of course where the router comes into play. So if you have, for instance, and what Brent's talking about, of course, is you have the your WAN or WAN, your wide area network, which is of course the web, the internet. And then you have your local area network or your local addresses. Now, the local addresses are what is known as private IP addresses. With the private IP addresses, what you run into with that is there's 3 or 4, and I only have information for 3 of them. Gary, one of our guys over in our tech department or IT department, pardon me. He said 4 at one point, and I wasn't able to find the 4th one, but he's way more knowledgeable when it comes to that, and I wanted to get more research, but unfortunately, he's super busy today. So
we're doing a new phone system.
Which I'm sure he's thrilled about right now, and hey, he's having to figure out IP addresses when it comes to that. So with IPv4, there's 3 or 4 private IP address ranges. Now those ranges are used only for local networks. So for instance, let's use just a very simple example of this. At my house, I have a modem and a router. Now, my external IP address is something. I'm not going to tell you what it is because I don't want anybody doing anything with it.
Really?
Yeah,
no, I know. Of all the fun possible things you won't share with me.
Exactly. But what I will say is that my internal addresses are a 192.168. whatever.
Because you just did a default out of the box.
Just default out of the box. I don't have a massive control system at my house. I don't need to do anything special with it. So that's what my IP addresses are. Now, there are other ones as well. So 192.168.0.0 is, everyone's probably used to that one because that was the first one to go to. Then we have 172.16.0.0. Now, there's a difference here. And Brent, I'm actually going to push you off to the side because I want to talk about this. I'm going to use the board here a little bit. We'll switch this over to the top-down view. Okay, so the really great thing about, you can see my notes here actually in the view. So you've got 192.168.0.0. So 192.168.0.0. Now, what this of course means is that I have the ability to use this octet is the word for that, O-C-T-E-T, that octet for the subnetting. And what that means then, of course, is that that opens up the ability for me to have extra addresses in different subnets and separate out my network. We're going to get into that in another episode. But we also have other ones as well. So we've got 172.16.0.0, and I'm actually going to show you this because what happens here is we're going to put a slash, and this is going to be 16. This is going to be slash, and this is going to be 12. And then last we've got 10.0.0.0. Put a slash on that, and that's going to be 8. Now, what this basically means is that with all of these addresses here, these private addresses are not used on the on the internet. They're not used on the outside of your router or your local network. And the reason for that is that they realized that they were going to run into the problem of not having enough IP addresses. So what they did instead is they made sure, hey, we've got enough IP addresses because not every single device is going to have its own dedicated IP address. This laptop here at work has an IP address of 192.168. whatever, which may be the same 192.168 as my computer at home. Now, that's okay though because there's no miscommunication there because they're on separate networks. This
now, let me
may
ask you a
seem
question.
pretty basic.
If you were to take that laptop home and dump it onto your network, because that's probably a dynamic setup right now.
Correct.
So it might actually have a different address at your house
exactly
than it does here because it's not static.
Exactly, and that's where we come into DHCP or static IP addressing,
which is a future episode.
Which is a future episode, and we do want to talk about that because that is another thing that needs to be talked about when it comes to networking. But we'll talk about that later. So, again, if anybody has any questions about anything that we're talking about today, please put it over in the chat section, or if you have a comment about what we're talking about, or even if it has nothing to do with what we're saying today, please put it over in the chat or down in the comment section below. We're always happy to hear stories about everything going on in the AV world. And then, of course, Brent, where can they find us? Facebook, Twitter?
Facebook, Twitter, Instagram, YouTube.
Well, I mean, if they found us here, they know we're here already.
Any place else we are, young man?
No, I think that covers it all.
That covers it all. Okay.
Okay.
I think LinkedIn maybe.
We do have a LinkedIn.
Do we have a LinkedIn?
We
okay.
do.
So with all of that, yes, you are correct. If I were to take this laptop home and let's say it's a 192.168.1.10, right? And it's the same address that I have on my other laptop at home. Now, if I take this laptop back to my house and I plug it in or hook it up to the same network, whether it be Wi-Fi or plug it in physically, I'm going to get hopefully a different address than the same one as what the other laptop is, so long as I have this laptop on DHCP or where it's asking the router for an IP address, which again is an entirely other episode. I don't want to get too far into that. So the reason that they gave you local addresses is because they were running out of addresses and they knew that. So they decided that this is a really good way to kind of separate everything down into the different network segments. So what you run into, of course, is the layout for everything is, did I get that right? The last address in the subnet is for dividing the subnet. Okay, so anyway, so when we look at the structure of an IP address, when you see a local address, what you're going to run into on the local address is actually kind of interesting because the first, depending on what this number is here, which is actually another part that I'm getting a little bit ahead of myself, but this number here tells us how many IP addresses we have to work with. I didn't switch over. There we go. This number here tells us how many IP addresses that we have to work with. So when we look at the fact that we're using 192.168.0.0, that's actually a very small, it's a much smaller number, but it's actually, for all the private IP addresses, let's see, this one here, 10.0 has a total of 16 million addresses. It's actually close to 17 million. This one here has 1.04 million. And then, of course, 192.168 has about 65,536, so 65,005. So you can tell that the 192.168 is actually a fairly small number compared to what the other addresses are capable of doing. And to be honest, if you have 65,000 devices on your network, this is not for your house. This is probably not even an automation system like Control4 Crestron or whoever else, because 65,000 devices is a lot, and there'd be a lot of chatter going on, and you would have things separated out in a much different way.
Even in a basic network in your home now, you've probably got between 12 and 20 devices, just and not counting subnets.
Right.
Which, if you're doing video surveillance, you probably should have that subnetted out.
Yes, you should. So for security reasons, and that's another episode. We're going to talk about security and firewalls.
Wow. So this is a big series.
This is a really big series, and honestly, the reason for this is that we keep getting phone calls about IP addressing for surveillance and you know how to do it or what to look for. So we really wanted to get this information out there for that reason. So, okay. So now that we know that the local addresses are something that's separate from the addresses that you would see out on the WAN or the internet connection, and the reason for that, of course, what about IPv6? I stole your line. I stole your question.
Well, that's okay, because here's something I do know. Most of the modems we're getting now are an IPv6 address, but that's within the system.
A lot of the new ones,
So it's not something you typically have to address yourself.
Right, and actually we ran into this ourselves here, not at our site, but we were remoting into a client to help out with some tech support. And when we got into the computer, we did just a Google search. What is my IP? Which is Google is great for that because it gives you an IP address as what your outside IP address is. We were going to do some port forwarding. So with that, when I did that, it came back with a very long number, and I was like, well, that's not an IP address. Well, it's not an IPv4 address. It was an IPv6. We saw it specifically on an AT&T fiber connection. So when you go in, if anybody's dealing with AT&T fiber, I think even the Fios, the Verizon Fios, may also be IPv6. Spectrum, I'm not sure if they're doing that or not. If you know, let us know over in the chat or down in the comments below. So what about IPv6? The biggest difference between, and I'm not going to get too far into IPv6 because there is so much information when it comes to that, and I don't know enough about it, but I do know that with IPv4, we have a total of 4 billion, or just over 4 billion.
4.3 billion.
Exactly, 4.3 billion. But with IPv6, instead of being a 32-bit size, it is actually 128 bits.
Now, I have never seen this word before.
So there, 128 bits is 4 times the number of bits, but that doesn't mean it's just 4 times the amount of numbers that they have to work with, or combinations.
Right, it's times.
Exactly, we're just adding additional times onto that. So let's see if I can write this out. I should have written this out ahead of time so it was already on the screen, but we'll see how long it takes. So, actually, Brent, here's one for you. While I write this out, how many? I'm going to challenge you to say that word.
I'm going to call it as undecillion.
Undecillion. That is correct, actually.
Undecillion.
Yep. So with this here,
which, by the way, I had never seen prior to you handing me this. Now, the number associated with it, that 10 to the 36 power.
Yep.
That one I understand.
There you go. So we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 spaces, 12 times 3 is 36. So 340 with 36 zeros after it is the number of IP addresses that we have available to us. It's actually more than that. I zeroed out a couple of them.
What, you didn't do the whole thing?
I did not. I started doing this, and then Pavlov took over, and I started writing out the actual numbers for it. And so I just kind of ran with it. So
That's right.
It's one. Let's see. It's 300. It's 340 times 1. 340 times 10
To the 36th power.
to the 36th power, or 3.4 times 10 to the 36th power. So it is an insane amount of addresses. It's not big enough to be like, more atoms than is in the observable universe large, but it's a very large number.
God, I don't want that many atoms in my life.
You've already got too many, right? You've got one.
One's more than sufficient.
So, and again, I don't want to get too far into IPv6. There's the structure of IPv6 today. Yeah, I do want to do an episode on it once I get more information myself and learn about it myself. But the main takeaway from that is IPv6 is coming. It's already here in certain aspects. The way that you're going to use it, you have to change the way that you think about IP addressing, layering your network. It changes all that kind of stuff. But we'll do an entire episode probably on IPv6.
I remember the fourth one. It's 168, which is nowhere. The fourth,
yes.
The fourth is 168.
Which is a really small one because it's only one
It's kind
address.
of a default when there's a problem.
Right. Yeah. It's one address, and in fact, that does lead us into it's like 168, and I'm not remember what it is, so I'll put X's to take their place.
I think it's .0.0.1.
But that's actually with -24. So that's important because -24, and I'm going to switch over here to the other camera. This -24 is actually really important because, and again, all these other numbers are important after the dash. Do you know why, Brent?
I do not know why, Adam.
Okay.
Will you tell me?
So before I go there, I need to clean this off.
Step away.
Yep.
Keep talking.
Before I go into that of why it's important, we first have to understand what does an IP address really look like. And what I mean by that is, what does it look like as a binary number? Take a look here real quick. Oh, it's Phaetonia. You just aged yourself, Brent, with the Jeopardy reference. Yeah, good job with that.
If aging myself is the least of my worries.
Yeah, right. Again, everybody, thank you for joining us in today's episode. As always, if you have questions about what we're talking about today, put it over in the chat or down in the comment section below. We would really appreciate that. Okay, so what does an IP address really look like? And this is actually really important for why you have the slash and then whatever. So we're
now,
gonna switch
I
over
will
to that.
admit I have never applied this thought process.
Yeah, you've never looked at
this.
this.
Makes sense.
It makes more sense, right?
Yeah,
Okay.
but I've never thought about it in these terms.
So when we look at an IP address, and I'm going to start simple. I'm just going to do 192.168.0.0. So 192.168.0.0. So when you convert this over to a binary number, what's going to run into is you've got octets. And the reason that it's octets is because each one of these, this here, that's 8 bits. This is 8 bits. Technically, this is 8 bits. And of course, this one here is 8 bits as well. That's why we have 8, 16, 24, and 32. That's why it's a 32-bit
Right, because it's actually a 3-position number for each of those dots. We just don't fill them in if it's a 0.
Right, exactly. So yeah, normally it would actually look like 192.168.000.000. Because technically it is three characters at that point. But to shorten things up, they take out the leading zeros. The leading zeros. They do leave the 0 at the last point if there is one. But normally they take out the leading zeros. So what does this number actually look like? Well, when you break it down into binary, the first octet is going to be 8 bits long, or 8 characters long. So what we have is 1 1, and then it's followed by 6 zeros. And what that basically means is 192. When you look at binary, this is a 1, this is a 2, right? So here's where, that's 1, and that's 2. If you do 2 characters, so you can do, that's still 1, and then you would do this here, that's a 2. So 1, when it comes to characters, and that's a 2. If you count to 3, it's going to be, what is it? Is 3 1 0, or is it 1 1?
It'd be 1 0.
1 0. And then 4 is 1 1. Right?
Yes.
Yes, I did do that right. So, with that, what we run into, can you grab a towel?
A couple of dry ones.
So when we look at the IP addressing in the binary, instead, what we run into is a number like this. 0, 1, whoops, get rid of that. 2, 3, and then of course it's all zeros from here. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Yep, there we go. So, and then of course 172.16.0.0 is another one. 10.0.0.0. The 10.0.0.0 is actually kind of interesting. We've got 10.0, thank you. .0.0.0. And when you look at that, that actually winds up being 0, 0, 0, 0, not 6, 0, 1, 0, 1, 0, and then of course it's followed by a bunch of zeros after that. So, Brent, where's your paper? You can ask this question.
Okay, what question am I?
The last one on the first sheet.
Why is this important?
Okay.
I feel so important now.
So this is important. Good job, Brent. You did your job. So
and
this
for
is
this
important.
I get paid.
Yeah. This is important because of the fact that of 192.168.0.0/16. Now, what this 16 means is that the first 16 digits of the binary number are fixed numbers. This is actually what's known as the network number. So when you look at this and we break down the binary, we'll go back here. So we have 192.168.0.0.16. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So now, surprisingly, it's actually just half, of course, because we're doing 32. So half of 32 is 16, so it's pretty straightforward. So what that means is that this first set of numbers here, 192.168, is our network number. And what that means is that that's the fixed number for that network. If you were doing 10.0.0.0, that's actually a /8. So we're left with the 16, a /16, we're left with 2 octets worth of numbers. That's how we got to the number of 65,000 addresses, right? So 65,000 addresses. This is a lot of information, and doing research on this was great. It's a lot of fun. Because honestly, until just last week, I did not understand this myself, so I learned this myself. So when we look at the 8, you would think, well, Brent,
it's the first 8.
It's the first 8. You are correct, but 8's smaller than 16. How the heck do I have?
Because now we have
more
the
characters?
rest of the number.
We have the rest of the number, exactly. So when we look at 10.0, we have 0, 0, 0, 0, 1, 0, 1, 0, and then of course it's followed by another 24 zeros, right? After that. What that means is that the first 8 digits of the binary number are what's called our network number. So that's the fixed number in the IP address that says this number here is specifically for saying this is the local network. So inside of the routing portion of it, your system, whether it be the system will look at that number first, and if it's 10 or 192.168, or if it's 172.1, let's see, where'd it go? 172.16, it will know, okay, that's a local address. I do not want to send that address outside to the internet because they're looking for a specific address inside this local system.
Which is why you never pick a number other than these for your local network, because it will create much havoc.
Exactly. It'll try to go out to the rest of the internet.
And then you will have conflicting addresses with somebody else.
Yeah, so yeah, exactly. You may try and connect to somebody over in China or somewhere else like that. So watch out for that. So what that does then is, like I said, it shows you where the dedicated portion of it, where the network number is. And that separates that out from trying to go out to the rest of the internet and trying to connect to somebody who's way out there doing something else. And you're going to get a denial because it's always going to be behind a firewall of some kind, and you're not going to be able to connect to it and all that kind of good stuff.
And if you do connect to it, God help you.
Yeah, you're just going to be screwing everything up. Okay. So
Do
lower
I get
the
to
number.
ask the next question?
Yeah,
Not yet.
Not yet, because
Okay,
basically
so
I just
let's
want
get to the 168, which is a 24 number, and why it has so few addresses.
Exactly. So good point. So when you look at, and actually I'll flip back over here to this, when you look at, and Brent made a good point with this. So we were
Which
saying
is
before.
why typically a 168 is considered a bad number and there's a problem in the network.
So a 168 number, and I don't know what it is. I'm pretty sure you're right. I think it is just zeros, and then it's usually a /24. Now, this is important when you look at this, and we're going to get into the routing tables and how they work, and that's where these really come into play. But this will kind of give you an overview. So 168. Now, actually no, that's wrong. It's a 32. It's not a 24. It's a 32.
Really?
Yeah, because 24 would just be the first 3 octets. It wouldn't be the all 4 of them. So with 32, you can see that, okay, well, there's 8 bits. There's another 8 bits, so that's 16, 24, and then this last one, that's all of the addresses that we have is 32. So that means 32 of the binary numbers, all the way up to 32 ones, I'm not going to draw it out again, all of those added all the way up means that we're going to use one single IP address. We are not going to use that IP address for anything else other than what you were saying, which is like a warning IP address.
Yes.
So this number here, if you see in your routing tables, and we'll get to an episode on the routing tables, but when you see that number 32, that means it is literally looking for one specific address.
Yeah, it is not an advantage to raise your routing table numbers.
Yeah, no, exactly. So, Brent.
Yes, sir.
Next question. You keep hitting buttons. That's what it is. I keep hitting buttons over here. You keep hitting buttons on your side. That's what it is.
That's because I'm faster on the draw.
Are you?
So, /.
Oh,
what
well,
is it and
we
why?
just talked about that.
We did?
Yeah. Oh, it turned off. Look at that. Okay, so
Wait a minute. We talked about numbers. Where did the / come in?
this here. So when you have the
that's just the
192.168,
differentiator.
that's,
Okay.
yeah, that's the thing that actually breaks that
Okay,
apart.
you didn't.
Yep.
Okay, so that wasn't a question I actually needed to ask.
No,
Who broke the TV?
I'm going to go with you because I'm not entirely sure, but I'm going to go with you anyways.
Should we call Brent or Adam?
We're going to call Adam because Adam knows how to fix it.
Does he now?
We're going to go with that. So when we are, again, everybody, thank you for checking in with us today. We really appreciate you. We're going to make that stop there.
Did you have that as a static or do you have it playing?
I had it static.
There's the
but
problem.
I put it up for too long and it went to sleep. So again, everybody, thank you for checking in. If you have questions about what we're talking about today, please, of course, leave it over in the chat section over there. Or, of course, you can leave it down in the comments if you're viewing this after the fact. Phaetonia says, remember, everyone gets a trophy for participating today, so as not to upset the precious snowflakes out there.
Okay, the only trophy on this table goes to me because I have to tolerate you. Or is it the other way around?
I was going to say, I think I get a trophy for that one, right? I mean,
As the third party in here, Adam gets the trophy.
Okay, so
thanks, Brandon.
next question.
Next question.
Tell me about my Apple address.
So,
But
okay.
it's not.
It is not an Apple product address. It is not a Macintosh address. It is a Mac address. In fact, Mac address, do you know what Mac address stands for?
It means multi-access control.
No, it does not. Well, it does, but it doesn't. Not in this aspect. MAC address stands for Media Access Control Address. So what it is, it's a unique identifier. I'm going to read directly from Wikipedia on this. So if it's wrong, we're going to blame the editors on Wikipedia. It says, a MAC address is a unique identifier assigned to a network interface controller, or NIC, N-I-C, for use as a network address in communications within a network segment.
We used to call them ESNs in the days of cell phones.
Sure. So
Electronic serial number?
And actually, ESNs are still there and running, and it uses the same basic structure, but
Just
it's slightly different. Yeah, slightly different.
But that's effectively...
Yeah. Now, in fact, what's interesting, as I was doing research, your Bluetooth connection uses a MAC address
it has
to know what to connect to. So you'll see that on there as well. If you do like a command line on a Windows machine, and you do ipconfig /all, that will actually show you, if you have a Bluetooth connection, it'll show you a MAC address for your Bluetooth connection as well. I thought that was kind of interesting. So a MAC address, of course, it was originally created by Xerox Network Systems and their Ethernet addressing scheme. So, of course, remember we were talking about
And who stole the Xerox operating system?
That was Jobs.
And what company?
For Mac. Yeah. Wait, was it?
It was
no,
Jobs.
did he? Was it Jobs that did
It was
that,
Jobs.
or did he steal
he stole the mouse? And
That's what it was. It was
which
the
was
mouse.
all part of Xerox.
Yeah.
Windows bought somebody else's for next to nothing.
Yeah. So that's what it was. Yeah. He found the guy in a dumpster. So
It's where we're going after this show.
This is a fun one. Okay, so MAC addresses are recognized as 6 groups of 2 hexadecimal digits separated by hyphens, colons, or without a separator.
So, Vision and Wanda play in this. It's a hex.
Sure. I haven't watched that yet. Is it good? Have you watched it?
Okay. I got to get Disney.
Okay. So when you look at, see, you did it again, darn it. You went
I didn't
ahead
touch
and
any buttons.
You did
I
do
didn't.
it. I hit the
didn't.
button. You screwed it up over there. I'm going to blame you for it.
Yeah, I'm going to blame. That one's your fault.
Okay.
Not mine.
So what does a MAC address look like, Brent?
Bunch of zeros with
Well,
separators in 2 digits.
This is this is a fake one here. So of course this would normally be filled
or
out.
octets. It's just 2.
Yep. I need 2 more sets.
You got a dirty board.
I do have a dirty board. So when you look at a MAC address, what the MAC address is going to do is it's going to be kind of like it's not a phone number. So an IP address is like a phone number because the IP address can change. It could be, you could have a phone number
dynamic or static.
Yeah, it could be 555, it could be 386,
This
it could
is
be
a
whatever.
serial number.
This is more like a social security number, right?
For old people?
Sure. So this is like a social security number because this number here is given to you and it should not change. It can change in certain circumstances. There are certain times where, anybody who's had to deal with anything like that, where maybe you lost your social security number or it got, taken or whatever else and you've had to deal with that, it can change. But in most cases, it's a burned-in number. It's a number that doesn't change. It gets fixed. So what that's used for in multiple applications is a way for the system to find, or a device on a network, to find another device on a network as well, or on the same network. Because it will send out a broadcast specifically looking for a MAC address, and it will find it from, or the device that's listening will listen for its own MAC address and say, oh, that's me, I'm going to go ahead and connect to it. That's also how certain features work, like on Control 4's SDDP. They work more on a heartbeat, if I remember correctly, rather than using the MAC address, but I think it uses the MAC address to verify if it's a device that has SDDP.
Now, let's say you have 2 devices that maybe one of them set static and one of them's dynamic that are sharing the same IP address. Does the MAC address at that point help identify which is which? And do different manufacturers purchase blocks of MAC addresses to help determine who and what they are?
Yes. So when you look at, in fact, another...
Was that not a great lead-in question?
That was a great lead-in question, Brent. You did great. In fact, that was a question I did not have on the sheet. So kudos, you get a trophy today.
I'm not too proud to accept that.
So
see, I get a trophy.
Yeah, there you go. So when we look at the MAC address and how it's used, you can actually look at our own SpyClops systems. So when you purchase a bunch of SpyClops cameras and you're using a laptop and you use our search tool, the great thing is that those cameras come with a static IP address. They don't come with a dynamic IP address, which means that it's always going to be set to one address when you take it out of the box.
Every camera.
Every camera. Now, it's not the same IP address. Our fixed cameras are 192.168.1.168. Our PTZs are 192.168.1.110. And our Wi-Fi
fairly
camera...
common default addresses.
Yes. And our Wi-Fi cameras are 192.168.1.120.
That's an uncommon address.
That is an uncommon address. So, the reason that that they can find all of the cameras, even though they share the same IP address, is because every single camera has a different MAC address. And that's how it does it.
By the way, and when you look at our matrices, for example, we purchased a block
Yes, we did.
of MAC addresses so that we do know our range.
That's right. So if you use a tool like Fing or Angry IP or Advanced IP Scanner, a lot of times it'll show you who the manufacturer is, and that's where in the MAC address, how we know who built the device, because it's using the MAC address. It's actually using the first 3 octets, which is this here.
As the product manufacturer identifier.
As the product manufacturer identifier, exactly. So if you were to see this, Control 4 has a really good one. Theirs is really easy to remember. Theirs is FFFF. Is it 3? It is 3 Fs. 0, 0, 0. So this is like the Control 4 one. And the only reason I remember this is because this is one of the things that we always had to tell tech support whenever we called in. Is that, and I always remember that would always be the first one as the opening for that. But well, yes, you are correct.
So it's a fluffy feather failure.
Sure. So with that, what we did, of course, like you said, is our matrices, we went out and actually purchased a bunch of MAC addresses. That way, when you do a scan on the network, you will see Ethereal, or is it Ethereal or Metra? I can't remember which one.
Ethereal, I believe.
I think so. So when you do a scan for it, you'll see either Ethereal or Metra on the network, and that's the device that you want to connect
And it's easy to find us.
Exactly. Yeah. So with the MAC addresses, like I said, those are primarily going to be like a social security number. They're going to be like for the most part, they're going to be a fixed number that's not normally changed. In most devices, it's going to be fixed. It's not going to be changed at all. Some devices, you can mask it and use a different MAC address and other things like that. But for the most part, that's really what a MAC address is, and what it does, it's just basically a serial number to that specific NIC or network interface controller.
Oh, I got a question for you that you're going to want to get mad at me about, but keep going.
Oh, okay, all right. Well, that's pretty much it. You have anything else?
Are you ready to talk about subnet mask, or are we going to make that another episode?
That's going to be another episode.
Okay.
Yeah, that's going to be another episode, because subnet masking is kind of interesting. You have to have you have to understand this first before we get into that, because that's another topic basically on its own. So, yeah.
Okay then.
Yeah, not yet. So, with that, everybody, that's pretty much it.
Well, that was a lot.
And within 45 minutes, I would be very proud of myself for getting it out there for that. I'll get a trophy for that one. All right. Anyways, everybody.
My guess earlier is this was going to be a 35-minute broadcast.
I was hopeful for 35 minutes.
But it wasn't.
But there's so much information when it comes to even something basic like that.
And it's funny because it seems so basic on the question sheet.
Yeah.
There's 4 questions. How hard can this be?
Yeah.
Well, guess what?
There's a lot.
There's a lot.
There's definitely a lot.
And here's the thing, guys. Do not feel bad about not understanding this. There's a lot that goes in the back end before broadcast here that we study, we learn. In this case, this was all him. All I had to do was stand there and look old. And I'm good at that. But there is a lot to know on this. If you have any questions, don't hesitate to call us or put it on the YouTube site. We will check it and we do answer.
That's right.
Well, this would be his.
Groove Music, it's great to see it as well. And yes, thank you for the thank you. And we try to be as helpful as we possibly can. So if we helped out, give us a like and share it out to any websites or groups that you're part of.
Tell your friends, tell your neighbors, tell your parents.
Yeah, we're shooting for the 2,000 subscribers. We're already 2/10 of the way there. So hopefully we're almost a quarter of the way there now. We're over
half the way there.
We're over halfway there.
We are
in the 2000s.
We're at 1250-ish.
Roughly, yeah.
So that puts us just under 6/10 of the way there.
6/10. Just over 6/10. Just over 6/10.
Just under, just over.
Something like that. We're almost there, guys. We're going to try to get there as soon as possible.
Will be 75%.
Sure. I believe you. Okay, everybody, thank you for checking in with us today. I had a great time with it. A lot of questions for all of that good stuff that was going on with it. Brent, do you have anything else that you want to plug?
I don't.
Or anything?
I would like to say in the following weeks, you will see some changes in the studio. Adam finally has an office to himself now.
I do.
So it will be hopefully a little cleaner, a little bit better organized, and we can possibly even spread the studio out a little bit more.
Hopefully, yeah. Maybe we'll get some more stuff in here or something.
So we are very excited about that. They are updating the phone system for the company, so if you do call and you don't get us instantly, we are not ignoring you.
Yep.
Please try again. You can easily reach me. You can certainly always reach Adam.
Yep.
Don't hesitate to contact us.
Yeah, and we're here to help.
On that note,
reboot early.
Reboot often.
Don't cut your wires too short.
And call tech support.
Turn off CEC.
Turn off CEC.
And call tech support.
There was another one today, guys.
I don't remember what it is. We were on the scroll. You got like 10 seconds.
Yeah. We're going to do an episode. I'm going to do a video on the JR3 anyways.
That'll work.
Remember, always one resolution. Keep your settings simple, guys.
Sure.
Never select auto. And damn it, I had something I wanted to say at the beginning, but I'm old.
Nope.
I'm Brent.
I'm Adam.
We're out of here.
See you guys.